Okay, one more time. So before we start our lesson today, I want you guys to go to the very back page of your packet. There's like a blank page there. And we're going to review just a couple things that we'll need later in our lesson. And if we remind ourselves of these things really good, then it should make the lesson pretty easy. Okay, so the first thing I want to review is weird like terms. Okay. Okay, so you guys already know that like a normal situation that has like terms would be like if I did 3x plus 2x, right? Those are the exact same letter. They have the exact same exponent. So to combine them, you leave the x alone and you just add the coefficients together, right? You guys have been doing that for years. Easy peasy, right? Okay, so what if I had something like this? If I had 3 plus 2 square root of 5, okay, can I combine those together? No, the root part is almost kind of like the x part. These ones won't combine because of their addition, and they're not considered like terms, okay? Now, what if I had 3 root 5 and 2 root 5? Then I can combine them. So the root 5 is like the x, okay? Now, if I combine those, just like the x stayed by itself, the root 5 stays by itself. So I have 5 square root 5. Does that make sense?
Wait, so on this one, do you just add the outside?
Yep,
numbers?
it's the coefficient. You add the outside numbers just like with what we did up here on the one with the x's. Does that make sense? Good question. Okay, same goes when I have imaginary things. If I had 3 plus 2i, I can't combine those. One's real and one's imaginary. Okay? But if I had 3i and 2i, then I could combine them. Okay? So just like terms deal with variables, I just wanted to review just to help us out that so are rationals and so are i's. Okay. Does anyone have any questions on the like terms? Okay, the other thing I wanted to review real quick is weird radicals. We're going to deal with some weird radicals today. Okay, so I'm going to start normal and we'll get a little bit more difficult as we go. Okay, what's the square root of 25? Okay, you guys know how to do a radical. Good job. Okay, I'm going to get a little harder. What's the square root of negative 4? 2i. So when the negative is inside the radical, the square root, it's like square root of negative 1, so then it needs an I. Okay, so then what's the negative square root of negative 9?
3.
Negative 3? I? Okay, I agree. The weird thing on this one, a lot of people think that two negatives would make a positive, but do you see how one's in the root, one's out of the root? You can't combine them, okay, because one's inside the root. So this negative makes my answer negative. The negative inside the root makes the I, and then the square root of 9 is 3. Okay? You'll see why in a little bit when we have to add this. We're basically going to combine this stuff with what we did last time, so I wanted to review this stuff separate. Okay? All right, I'm going to get a little weirder. Square root negative 7. Anyone have any guesses? Can I simplify square root 7?
It would be 2 over, or it's not 2, it's 4 over 3. It's just that, isn't it?
No, because I can't.
Something over.
No, not on this one because there's no fraction here. Maya?
Is it I square root 7?
Yeah, good job. I square root 7. The 7 is prime, so it can't simplify, but the negative inside the square root, I can still take the I out. Okay? Let's do a couple more like this, and then I think we're ready to apply it to what we did last time. So then I have, what if I had square root negative 40? Okay? So what I would probably do is deal with the I first so I can forget it's there. So I'd first change it to be I square root 40. Then I start making a factor tree, right? Okay, so it ends in 0, so I could start with 10. So 4 and 10, 2 and 2, 2 and 5. I'm looking for pairs. Does the pair come out or stay in?
Goes out.
Out. Good. And then do I add the leftovers or multiply the leftovers? Always multiply because it's called a factor tree. Factors is always multiplying. Good. So this one would be 2i square root 10. The two leftovers multiplied together. I didn't have a pair.
How did you get the 2?
That's the pair.
And then the 10 just timesing those pairs together.
No, not the pairs, the non-pairs. The 2 and the 5 there make the 10. And then the pair of 2s is that 2. Okay. Okay, I want you guys to try one of these on your own, and then I'll walk around, and if you get it right and I feel good about it, then we'll move on to the lesson. So I'm going to give you one more of these to try on your own. Okay, let's do... negative square root negative 50. So I want you to take a second, and I want you to try that on your own. Okay. If you're watching the video, I'm just going to write it out real quick, and then we'll move on to the lesson.